Okay, in this video we are going to start 9.2. This is dealing with the Pythagorean theorem again, but what we're doing is we're more of labeling. So this one is more about the angles within and how they correlate with the sides that they are across from. So the first one has to deal with theorem 9.4, which is the 45, 45, 90 theorem. And what it states, say you have a right triangle here, and you know this here is 90 degrees. If this one here is 45 degrees, and this angle here is 45 degrees, then this is true about the sides. So if the sides are going to be across from the two 45s, then they are the same length. So we're going to call this X and this one X. So no matter what, if this is a 45, 45, 90 triangle, and the two sides that have the 45 angle, or the two angles have the 45s, the sides directly across from them are the ones that are going to be the same length. Now the hypotenuse is actually going to be x square root 2. So here's how this goes. Hypotenuse is always going to be equal to leg times square root 2. So that's how your distance is going to be found. The second theorem that we're going to talk about is the 30, 60, 90 theorem. The 30, 60, 90 theorem is similar to what we did here. The only difference is instead of being the same, the two angles are different. They still add up to make 90 degrees. So the smaller of the two angles, of course, is the 30. The next one is going to be the 60, and then we have the 90. If this is true, all three angles are different, okay? Which means that all three lengths will be different. They will not be the same on two of the sides. So as it goes, the smaller of the three angles is going to have the smaller length. So we're going to call that X. The longer of the two is by square root 3. So that means that the longer leg is square root 3 times as long as the shorter leg. So the shorter leg is X, and square root 3 then is behind it. The last one is the hypotenuse. The hypotenuse is twice the length of the shorter leg. So whatever the shorter leg is, it is 2 times the length. So in verbs or in phrasing, hypotenuse equals shorter leg times 2. So if you put it in groupings, this is shorter leg times 2. The longer leg, so longer leg, is equal to shorter leg times square root 3. This is what the theorem is talking about. So now let's put this into practice. So let's do a few problems that have to rely off these two theorems. So if we look at our note packet, we have these exercises. So for the first one, we know it's going to be the 45, 45, 90 because they tell us that this angle here is 45 degrees. So if that angle is 45 degrees, we know this angle up here is also 45 degrees. So to find the indicated X, what we have to do is go through the problem. If I tell you that this is 10, and I'm looking for this X over here, by theorem, up here, it is going to automatically be 10 square root 2 because it's always hypotenuse equals leg times square root 2. So our X value will then just be 10 square root 2 by definition. Look at number 2. Number 2, they are illustrating the same thing, but they are using a different way of doing it. So they're telling us that the two legs that we have here are actually the same length, and we want to know what the hypotenuse is. Well, we said the hypotenuse is always going to be times, whatever the side is, times square root 2. So if this is the case, x equals square root 2 over 2 times square root 2. Now remember, everything is over 1 originally. So what happens is I get square root 2 times square root 2, which we know to be square root 4. The square root of 4 is going to be 2. So 2 over 2 is the same as saying 1. Okay, let's look at number 3. So for number 3, we are told that the two lengths are the same. So this right here is x, and this over here is x. If we know both of those are going to be the same, that means by definition, this is 45 and this is also 45. So we know this is a 45, 45, 90 triangle. So if that is true, by definition, hypotenuse equals leg times square root 2. Well, if we know square root 2 is multiplied times the leg length, then the leg length has to be 8 using the hypotenuse setup. And last but not least, number 4, we have this here. And if you notice, this is all from the first theorem. We are just working with the first theorem on this. If this is x and this is 12, what is this, right? So if this is 45, we know this is 45. This is our hypotenuse. So this is the same as saying 12 equals x square root 2. So our answer, if we leave it in precise amounts, we know to undo multiplication, we have to do division. So here's where the rationalization comes into play. We can't leave that 12 over square root 2. So let's come over here and rationalize our fraction. So we have 12 over square root 2 times square root 2 over square root 2. We know square root 2 times itself is 4, which gives us 2. So I have 12 square root 2 over 2. 2 divides into 12 6 times. So this is 6. Square root 2 is what the length of my legs are going to be. So remember, when you're rationalizing these, you need to work on keeping an eye out for that bottom. So if the bottom is a radical, then we need to go through and rationalize it by simplifying it, not making it into decimal. Now, let's look at 5, 6, and 7. 5, 6, and 7 are going to be from your 30, 60, 90. So in this case, for number 5, we have a lovely right triangle here. This is our 30, and this is our 60. This is 15, this is x, and this is y. It says find the other two sides in simplified form. So the first thing we're going to do is look at our theorem. Our theorem says if the shorter side is my x, then to find this down here, we are going to put square root 3 behind it. So x is going to be 15 square root 3. My y is going to take whatever the shorter leg is and square it, or not square it, I'm sorry, times it times 2. So this is going to be 30. Number 6, same thing, right triangle. This over here is my 30, this over here is my 60. And they do this to help you identify the sides. This is y, this is x, and this is 22. So let's go backwards. We have the hypotenuse. To get the shortest leg, we divide it by 2. So the hypotenuse is 22. If we want the shorter leg, it's shorter leg times 2. So if we divide that by 2, then I'm going to get 11 equals my y. Now that I know what my y is going to be, we can say what the x is going to be. Because if you remember, the longer leg is the shorter leg times square root 3. So shorter leg is 11 times square root 3 is going to give me my x. So that's all we had to do for number 6. And number 7, same thing here. Lovely right triangle. That's X, that's Y, and we now have the B. So that's 30. My longer one over here is 60. So if my B is 9, then we have to work backwards. So that means that I had 9 equals. Remember, the formula is shorter leg, which in this case is X square root 3. So what I have to do here is take and divide both sides by square root 3, creating that unstable fraction. So now we're going to take and multiply both top and bottom by square root 3. Square root 3 times square root 3 is square root 9, which gives me 3. So I have 9 square root 3 over 3. And then I reduce my fraction, so it becomes 3 square root 3. So my shorter leg is going to be 3 square root 3, which is X. So X equals 3 square root 3. Now that we know that, we can actually do the hypotenuse. So once we have the hypotenuse, we know that it is hypotenuse equals 2 times the shorter leg. So if I know that, that means that I'm going to have H equals 2 times 3 square root 3. Now the good news is this is an easy multiplication because we don't worry about the radical. In this case, you treat the radical kind of like a variable. So I just multiply the 2 times the 3. So the hypotenuse is going to be 6 square root 3. So as you can see, we're going to be working more with radicals. So if you feel a little out of your element, make sure you go back to the 9.1 part of the video links I set up and watch the rationalizing radicals. This is all that you have to do for 9.2 at this time. The second part of it is basically setting up your own triangles and then doing the same processes. Good luck